Okay, we're here to talk about the Chapter 1 review that you have that's due Monday. Alright, so I want to go over the answers with you right now so you could check and see if you did everything correctly. So if we're looking at problem 1, we're going to find a pattern. Alright, and then show the next term. Well, we have 1, 3, 9, 7. 1, 3, 9, and 27, excuse me. Alright, so start out with 1, then we have 1 times 3, then we have 3 times 3, then we have 3 times 3 squared, then we have 3 times 3 cubed. Well, this equals 3 to the 4th, and 3 to the 4th is 81. For problem 2, if EG, that's the total length, equals 42, find the value of y. Well, we're going to do segment addition. So we're going to add segment EF, right? We're going to add segment EF to segment FG. And that should equal 42. Right? So we did some substitution. So we substituted 3y plus 4 for EF, and then 5y minus 2 for FG, and that should equal 42. So we combine like terms and get 8y plus 2 equals 42. And then we do subtraction property of equality, so we subtracted that 2. And then we divide by 8, so it's the division property of equality. So y equals 5, and 5 is answer F. Problem 3, find a pattern for the sequence. Use the pattern to show the next term. We have Sunday, Monday, Tuesday, Wednesday. Well, the next term is Thursday, or T. Alright. Problem 4 said, which net will fold to make a cube? Well, this one would be topless. So we don't have enough squares. G, right, if you fold the two sides up and this side over, this is the front flap, it'd be fine. No problems there. H, it also needs one more square. And J has an open side, so it needs another square, right? And plus, the way it's set up, it's going to cross over. We don't want it to cross over anything. Okay. So, for 5 to 8, it says use the figure at the right, which is right here. What is the intersection of plane GHIJ and plane CDIH? Well, CDIH is along the back, if you can see it. I'll shade it just a little bit. Alright, and GHIJ, right, GHIJ is the bottom. Alright, and they intersect in a line which is HI. Alright, you should be able to see that, and that's answer D. Which 4 points are coplanar? Well, we have A, B, E, those are all coplanar, and then we shoot down here to I. Nah, that's not on the same plane. We look at B, C, D, and E, and yes, they are all on the same plane. Now you can check the rest, A, C, F, and then H, no, and then E, F, I, and then K, which is way out here. Alright, so they're non-coplanar. What is another way to name plane ABEF? So we got ABEF. Well, ABEF is also part of ACDF. You notice that? It is part of the same plane. And BK goes right through it. what is the intersection of line BE and plane ACHG? Well, let's look at ACHG. That's right over here. We'll do that one just a little bit darker. All right. All right. So what is the intersection of BE? So where does BE, line BE, intersect? Well, right here at B, at one point. Remember, a line and a plane, all right, intersect at one point. All right. Now, find the value of x. Now, we're using this figure on the right, and I know that this angle, by the markings, is congruent to this angle. All right. So what I did was automatically, if they're congruent, this had nothing written. I copied 4x plus 5 degrees over here. Now notice this little box down here. That means that this is a right angle. And all the angles should add to 90 degrees. So we're going to use this fact that the sum of all these angles is 90 degrees, right? So we're just going to use the expression. So 4x plus 5 plus 8x plus 4x plus 5 all equal 90. Now I'm going to combine like terms. I'm going to do the subtraction property of equality, subtract that 10, and do the division property of equality, and I get that x equals 5. All right, and that's C. Problem 10, OM is the blank of LON. So here's LON, here's OM. Notice that the angles are congruent. So that makes OM the angle bisector. Okay, now we've gone through problem 10. Let's look at the next page. All right, now I asked you not to do problem 11. We're not going to see that. Problem 12 says find the value of x. All right, and we're using these two lines. All right. And when two lines intersect like this, it creates a straight angle. All right, straight angle. That means that 3x and x are supplementary, so they add to 180. So I can use that fact to solve for x. So 3x plus x equals 180. I'm going to combine like terms, and then I'm going to do the division property of equality to get x equals 45, and that's right here. Okay, which property of equality or congruence justifies the following? If segment LM is congruent to segment OP, then segment OP is congruent to segment LM. And you should know that that's not the reflexive property. That's the symmetric property. The reflexive property says it equals itself. Okay? Okay, this one's open-ended. It said to write two different patterns whose first three terms are 1, 2, 3, and then describe each pattern. So what I did was I come up with two patterns. 1, 2, 3, 4, 5, just the counting numbers. And then my other pattern that I came up with was 1, 2, 3, 1, 2, 3, 1, 2, 3. All right. You may have come across something different. If you did, let's talk about it in class. Can you make each conclusion from the information in the diagram? Please explain. Angle E is congruent to angle B. Well, I looked at this, right, and this is a triangle. I can also create another triangle from angle A on down. Right triangle using the height. All right, and you'll notice that the measure of angle E, since these are two right triangles. These two have to add to be 90 degrees. So the measure of angle E is 90 minus the measure of angle A. All right. And when I put this other height in, it's 90 degrees. I notice that the measure of angle B is also 90 minus A, which means they're congruent. Now EA and CB, there's no markings whatsoever to tell me that they're congruent, so you really can't do 16. Now 17, the measure of angle EDA plus the measure of angle ADC equals 180, which is true because both sides are 90 degrees, and if you add them together, you'll get 180. So that's true because both are right angles. Complete with always, sometimes, or never to make each statement true. 18. The intersection of two distinct planes is always one line. Now, in the book they said sometimes. If you can prove to me sometimes, if you can prove that to me, then we could talk some extra credit. But you have to write it up and bring it to class. Okay. Now, 19, the sum of the measures of two complementary angles is never 180. It's always 90. Writing. Explain whether the following definition of ruler is acceptable. A ruler is a tool used for measuring. It's not acceptable. It's too general an explanation. All right? We could actually go farther with a ruler. You can use a lot of different things for measuring. So that's not complete. We're going to do 21 and 22 in just a minute. So I want to go over the rest of the problems. Find the coordinate of point C, which was here, and it's -4 and -2. Can't hardly see my negative sign here, but you can see it over here. 24 was find the midpoint. So to get the midpoint, we had to add the two x values for both endpoints and divide by 2, and then add both y values together and divide by 2, and we have 0, -3. Now 25, we need to find the length of AB, right? So AB goes from here to here, right? And I use the distance formula, right? So I let this be x2, y2, and I let this be x1, y1, and I substitute it in, -2 minus 3 squared plus 2 minus 4 squared. Now that equaled 5 squared plus 2 squared, which is the square root of 29. So here's the square root of 29. I'll let that set here for just a second, and then we'll go over our constructions. Okay, you can always pause the video. So I want to move on. Right. And I'll just set this over here so I can see the problem. And we're going to construct. I went ahead and I drew, oh, I wrote it on here. Never mind, don't need that. We're going to construct the perpendicular bisector of EF. Right? And we went over this in class. I don't know if you remember it or not, but we did go over it. So, be right back.